Massive MIMO system for 5G and beyond network. First of all, we need to know why we are going to study this topic. The global bandwidth shortage in the wireless communication sector has motivated the study and exploration of wireless access technology known as massive multiple input, multiple output. Massive MIMO is one of the key enabling technology for next generation network which group together antennas at both transmitter and receiver to provide high spectral and energy efficiency using relatively simple processing. Obtaining a better understanding of the massive MIMO system to overcome the fundamental issues of this technology is vital for the successful deployment of 5G and beyond network to realize various applications of the intelligent sensing system. With globalization, present in network are facing high traffic demand. To fulfill this need, cellular systems are deployed within a few hundred-meter distance and wireless local area network LAN are placed almost everywhere. Along with increased mobile broadcast service, the introduction of new concepts like Internet of Things and machine-to-machine communication are also contributing to the increased wireless traffic. The global deployment of the cellular service cultivates the cell phone user to be used to the mobile data in their day-to-day lives tremendously. The service like video calling, online gaming, social media applications like Facebook, Twitter, WhatsApp have changed our lives drastically with the capabilities of the third generation, fourth generation, and fifth generation network like low latency, high data rate. A full cell phone connected world is expected in the next few years, with which will be mainly characterized by growth in user connectivity, data traffic volume, and a wide range of applications. We can see in the graph that the connected devices increasing per year and with corresponding to that the data traffic increasing. Wireless network. Wireless network need bandwidth, densify the cells to achieve the required area throughput, and spectral efficiency. An efficient wireless access technology can increase the wireless area throughput without increasing the bandwidth or densifying the cell is essential to achieving the MIMO stands for multiple input, multiple output. While it involves multiple technologies, MIMO can essentially be boiled down to the single principle and a wireless network that allows transmitting and receiving of more than one data signal simultaneously over the same radio channel. Standard MIMO network tend to use 2 to 4 antennas. Massive MIMO, on the other hand, is a MIMO system with an especially high number of antennas. Why we are in need of massive MIMO? Massive MIMO technology is used to deliver the need of 5G and beyond network. Massive MIMO is an extension of MIMO technology which involves using hundreds and even thousands of antennas attached to the base station to improve spectral efficiency and throughput. This technology is about bringing together antennas, radio, and spectrum together to enable higher capacity and speed of the incoming 5G. The increased throughput and spectral efficiency also increase the array gain. Massive MIMO and intelligent sensing system are linked. Now, cellular network. The mobile communication era started in the early 1980s, and since then, the mobile communication has experienced tremendous growth in the past few decades. Cellular networks have evolved from first generation to fifth generation and beyond. All the cellular networks are composed of base station, user equipment, phones, and or core networks. Here we can see the evolution of the mobile communication from first generation to fifth generation. Now, first generation. First generation, the mobile network were introduced in 1980s and used analog signal for voice only services. First generation system use FDMA and offer data rate up to 2.4 kilobytes. They had poor voice quality due to high interference, and the first generation include advanced mobile. The technologies, phone system, total access communication system are included in first generation. Second generation. The second generation mobile network were introduced in 1990s and were generally allowed digital version of first generation. Along with voice services they allowed message service and basic email service, and the system uses CDMA. CDMA and TDMA offer the data rate from 14.4 kilobytes to 64 kbs. Second generation system include global system for mobile communication and CDMA. Second generation mobile network were, as we know, that introduced in 1990s, and they are the digital version of the first generation. Now we move toward the third generation. Third generation is introduced in 2000 and were based on GSM and CDMA. They involved they evolved to get mobile phones along with voice, multimedia, message board, and SMS service. Third G system is UTMS and WCDMA. Smartphone became popular in mid 2000, and third generation network provide data rate upwards of 384 kilobytes, but they have required high bandwidth and complex infrastructure. Fourth generation. The fourth generation mobile network were introduced in the early 2010, and fourth generation network offer data rate up to 100 megabytes and can handle more data traffic with better quality of service. Fourth generation include applications like video conferencing, online gaming, mobile television. Fourth generation also include WiMAX, LTE, and LTA. The frequency band of the fourth generation are considerably expensive, and high-end 4G enabled cell phones are required to operate 4G network. 5G. The 5G mobile networks are currently starting to implement and aim to be 100 times faster than current 4G network. These are the few advantages of the 5G data rate. 5G network will provide data rate up to 10 Gbps, which is almost 100 times better than that of 4G network. Latency. 5G network provide latency as low as 1 millisecond compared to 10 millisecond latency provided by the 4G network. 5G efficient signaling. 5G network provide efficient signaling for IoT, net connectivity, and M2M communication. User experience. 5G enhanced augmented reality, virtual reality, and artificial intelligence. Spectral efficiency. 5G would provide 10 times more spectral and network efficiency compared to the 4G network. Energy efficiency. 5G network provide 90% more efficient network energy usage compared to 4G network. Battery life. 5G provide almost 10 years of the battery life for low-powered IoT devices. 5G provide huge broadcasting data which can support more than 65,000 connections, which is 100 times more than that of 4G network. Ubiquitous connection. Now we move toward what are the challenges of the 5G? Why are we not able to attain 5G till now? Frequency band. Frequency band up to 300 gigahertz have been considered for 5G network, and these high frequency bands are costly, and wireless carrier will have to pay millions to get this high frequency spectrum coverage. The high frequency wave has a shorter wavelength, thus it cannot travel a longer distance. Due to this issue, there should be more base stations in a smaller area to give each user a reliable connection. And the additional base station increase the cost and complexity of overall network cost. Since 5G is not just about adding an extra layer to the 4G network, the cost to build the system from the basic level is prohibitive. Device support. Since the phone available in the current market does not support 5G infrastructure, it would be a challenge for the device manufacturer to develop a cheap phone which can support 5G. Security and privacy. Although 5G uses the authentication of and key argument system, it is still vulnerable from attacks such as middleman attack, location tracking, etc. Availability. With the introduction of M2M, IoT network overload and would be a major problem in the future. The radio access network challenges will make it difficult to make the network available to everywhere. Cybercrime. With high speed data, cybercrime would increase disastrously, and thus restrict tribal law would be necessary to prevent these attacks. 6G. The 6G network, a complete wireless network with no limitation, it is currently in development stage, and it will provide incredibly transmission speed in the terabyte range. This technology would require a small antenna, large memory in the cell pool, and a huge optical network. The 6G network will be call free and would enable artificial intelligence in the wireless network. It is not clear what frequency band 6G network will use, but it is apparent that much higher frequency band will be needed to increase the data rate required for 4G network. While 5G is supposed to be used frequency greater than 30 GHz and up to 600 GHz, 6G is associated with much higher frequency in terabytes like 300 GHz or to 3 terabytes. The use of the terabyte spectrum from 3G is estimated to become a commercial in the next 5 to 7 years, and some of the applications for the 6G are connected mobiles and autonomy system, wireless brain computer interference, etc. Now, what are the advantages of the 6G data rate? 6G network is expected to be provide data rate up to 10 terabyte, which is almost 100 times more than that of the 5G latency. 6G provide a latency of zero point 0.1 millisecond compared to the 1 millisecond latency provided by the 5G network. 6G provide efficient signaling from massive IoT connectivity and M2M communication. 6G enhance extended reality, augmented reality, virtual reality, and artificial intelligence. Spectral efficiency 6G provide 10 times more spectral and network efficiency compared to that of 5G. 6G provide 100 times more efficient network energy usage compared to 5G network energy efficiency. Now, 6G will provide huge broadcasting data which can support more than 1 million connection, which is almost 100 times more than that of 5G connection, ubiquitous connection. The comparison between 4G, 5G, and 6G working is shown in this slide. Key enabling technology for 5G and beyond network. To make 5G and beyond network a reality, many advanced ideas have been proposed and analyzed in the recent year. The major key enabling technology that have been considered for 5G and 6G system include millimeter wave, small cell, beamforming, device-centric architecture, full duplex technology, massive MIMO, terahertz wave, and visible light spectrum. Multimeter and terahertz waveband is shown in the slide. Small, small cells or heterogeneous network. Small cells are the low power tiny base station that can be placed within every 100-meter distance to over small geographical areas. The low power base station prevent the signal from dropping in crowded area. Small cells are very light and small, and thus they are placed anywhere. If we are using multimeter wave instead of a traditional sub 6 GHz spectrum, the small cell can become even smaller and be fitted in tiny places. A small cell will play a significant role in delivering high-speed mobile broadcasts and ultra-low latency for 5G. Small cell can be further divided into microcells, picocells based on the coverage area and the number of users it can support. Beamforming. Beamforming is the ability of a base station to adopt the radiation pattern of the antenna. Beamforming helps the base station to find a suitable route to deliver data to the user, and it also reduces interference with nearby users along the road. Beamforming has several advantages for 5G network and beyond. Depending upon the situation, beamforming technology can be implemented in several different ways in future network. For massive MIMO system, beamforming helps with increasing the spectral efficiency, and for millimeter wave, it helps in boosting the data rate. In massive MIMO system, the base station can send data to the user from various paths, and beamforming here the packet movement and arrival time to allow more user to send the data simultaneously. Since the multimeter wave cannot penetrate through obstacle and do not propagate to longer distance due to the shorter wavelength, beamforming here helps to send the concentrated beams toward the user. Thus, the beamforming helps a user to receive a strong signal without interference with other user. Device-centric architecture. The current 4G system relies on the base station-centric architecture, where a device relies on a downlink and uplink connection and control and the data channel to obtain the service from the base station. With an increased number of users, a cell density or base station density is increasing rapidly, and the densification in the network would repair major challenges in the 5G and beyond network. Also, with the introduction of millimeter wave, Many frequency bands with entirely different propagation characteristics will coexist together. Thus, a base station centric architecture might evolve into a device centric architecture in the future network to overcome the challenges like network densification and increased frequency band. In the device centric architecture, a user device would communicate by exchanging the information through several heterogeneous nodes. Various research on the benefits of the device-centric architecture for 5G network are presented. A typically device-centric architecture is shown in a slide. Now, full duplex technology. Generally, wireless transmission and reception are not done at the same frequency band to avoid interference. Any bidirectional system thus has to separate the uplink and downlink channel using time or frequency domain to get orthogonal non-interfering signal. Full duplex refers to simultaneous transmission and reception over the same frequency band and at the time as shown in the figure. 5G network will use full duplex for the transmission of signal to potentially double the network capacity and is beneficial for higher layer. One of the disadvantages of full duplex technology is that it increases the signal interference through ego. Several studies have been conducted on full duplex technology and its benefit for 5G network. Here we can see that the up massive MIMO. MIMO systems are an integral part of the current wireless system, and in recent years they have been used extensively to achieve high spectral efficiency and energy efficiency. Before the introduction of the MIMO, single input and single output system were mostly used and which had a very low throughput and should not support a large number of users with high reliability. To accommodate the massive user demand, various new MIMO technology like single user MIMO, multiple user MIMO, and network MIMO were deployed. However, these new technology are also not enough to accommodate the ever increasing demand. The wireless user have to increase potential exponential in the last few years, and those users generate trillions of data that must be handled efficiently with more reliability. Additionally, there are billions of IoT devices having various applications to have smart healthcare, smart home, smart energy that introduce more data traffic. It is predicted that there will be around 50 billion connected devices by the end of the 2020. And the current MIMO technology associated with 4G LTE network is unable to handle this huge influx in the data traffic with more speed and reliability. Thus, the 5G is considering massive MIMO technology as a potential technology to overcome the problem created by massive data traffic and users. Several studies on the massive MIMO have been conducted on massive MIMO system and their benefit. Massive MIMO is most captivating technology for 5G and beyond the wireless access era. The massive MIMO is an advancement of contemporary MIMO system used in current wireless network, which group together hundreds and even thousands of antenna at a base station and serve 10 of users simultaneously. The extra antenna that massive MIMO use will help focus energy into a smaller region of the space to provide better spectral efficiency and throughput. Massive MIMO into a smaller region of a space provide better efficiency and throughput. Massive MIMO downlink and uplink system is shown in the slide. As the number of the antenna increases, as the number of antenna increases in massive MIMO, radiated beam become narrow and spectrally focused toward the user. The beam pattern for different antenna configuration is shown. The spectrally focused antenna beams increase the throughput of the desired user and reduce the interference of the neighboring user. Massive MIMO offer an immense advantage over the traditional MIMO system. The comparison of the traditional MIMO and the massive MIMO system is shown in the table. Now we move toward the uplink transmission. The uplink channel is used to transmit the data and the polar signal from the user terminal to the base station as we can see in the figure. Let us consider a massive MIMO uplink system equipped with M antennas at the base station and simultaneously communicating with N antennas. The M antenna should be greater than that of the N, the single antenna user. If a signal transmitted by the user or the pilot signal to estimate the channel is, for example, channel is X and it is an element of channel N. The signal received at the base station during the uplink is given by the equation as shown. The interference added is independent of the user signal X, but it is dependent on the channel H. Downlink transmission. The downlink channel is used to transmit the data or estimate the channel between the user and the base station. The base station using the training pilot to estimate the channel. A downlink transmission with several UE and a base station is shown. Let us consider downlink massive MIMO system where the base station equipped with M antennas and is serving end user having a single antenna simultaneously. The base station sends independent information to multiple users. And here is the equation for downlink. Now we will study the advantages of the massive MIMO in 5G and beyond network. Number one is spectral efficiency. Massive MIMO provides higher spectral efficiency by allowing its antenna array to focus narrow beam toward a user. The spectral efficiency more than 10 times better than the current MIMO system used for 4G LTE can be achieved. Energy efficiency. As antenna arrays focus on a small specific region, it requires less radiated power and reduce the energy requirement in massive MIMO system. High data rate. The array gain and spectacular multiplexing provided by the massive MIMO increase the data rate and capacity of wireless system. User tracking. Since massive MIMO use narrow signal beam toward the user tracking become more reliable and accurate. Low power consumption. Massive MIMO is built with the ultra power linear amplifier which eliminates the use of bulky electronic equipment in the system. The power consumption can be considerably reduced. Less fading. A large number of the antenna at the receiver make the massive MIMO resilient against fading. Low latency. Massive MIMO reduce the latency on the air interference. Robustness. Massive MIMO systems are robust against unattended interference and internal jamming. Also, these systems are robust to one or few antenna failures due to the large antennas. Reliability. A large number of antennas in massive MIMO provides more diversity gain, which increases the link reliability. Enhanced security. The massive MIMO provides more physical security due to the orthogonal mobile station channels narrowing the beams. Low complex linear processing. More number of base station antenna make the simple signal detectors and precoders optimal for the system. Challenging in massive MIMO and mitigation techniques. And these are the challenges in massive MIMO which we are going to face. Number one, pilot contamination. In massive MIMO system, the base station needs the channel response of the user terminal to get the estimate of the channel. The uplink channel is estimated by the base station when the user terminal sends the orthogonal pilot signal to the base station. Furthermore, with the help of the channel reciprocal property of massive MIMO, the base station estimates the downlink channel toward the user terminal. If the pilot signal in the home cell and the neighboring cell are orthogonal, the base station obtains the accurate estimation of the channel. However, the number of the orthogonal pilot channels in a given bandwidth and the pair is limited, which forces the reuse of the orthogonal pilots in the neighboring cell. The same set of the orthogonal pilots used in the neighboring cell will interfere with each other, and the base station will receive a linear combination of channel response from home cell and neighboring cells. The phenomenon is known as pilot contamination and its limit achievable throughput. Channel estimation. For a signal detection and decoding, massive MIMO relies on the channel state information CSI. CSI is the information of the state of communication link from the transmitter to the receiver and represent the combined effect of fading, scattering, and so forth. If the CSI is perfect, the performance of the massive MIMO grows linearly with the number of transmitting or receiving antenna whichever is less. Precoding. Precoding is the concept of the beamforming which supports the multiple streams transmission in multiple antenna systems. Precoding plays an imperative role in massive MIMO system as it can imitate the effect created by the path loss and interference and maximize the throughput. In massive MIMO system, the base station estimates the CSI with the help of uplink pilot signal or sent back by the user terminal. The received CSI at the base station is not user scheduling. Massive MIMO equipped with the large number of antennas at the base station can communicate with multiple users simultaneously. The simultaneous communication with multiple users create multiple user interference and degrade the throughput performance. Pre-coding methods are applied during the downlink to reduce the effect of multiple user interference as shown in the picture. Since the number of antennas is limited in massive MIMO base station, if the number of users becoming more than number of the antennas, proper user scheduling scheme is applied before pre-coding to achieve the higher throughput and some rate performance. There have been numerous studies in the last few decades to find an optimal scheduling algorithm for massive MIMO. Several linear methods such as ZFMMSE provide near optimal throughput performance and have acceptable computational complexity. The non-linear methods such as dirty paper coding and maximum likelihood provide near optimal performance, but they have higher computational complexity for a larger number of antennas. Several user scheduling algorithms have been proposed to improve the sum capacity, but computational complexity was not improved for the large number of antennas. Hardware impairment. Massive MIMO system depends upon a large number of antennas to reduce the effect of noise, fading, and interference. A large number of antennas in massive MIMO increase the system complexity and increase the hardware cost. To deploy massive MIMO, it should be built with low cost and small components to reduce the computational complexity and hardware size. The use of the low-cost component will increase the hardware imperfections such as phase noise, magnetization noise, amplifier distortion, IQ balance. These imperfections have a major pictorial performance due to the large number of antenna. There is a mutual coupling between the antenna element which changes the load impedance and cause distortions. Energy efficiency. Energy efficiency is the ratio of spectral efficiency and the transmit power, and the massive MIMO can provide substantial energy efficiency gain by achieving higher spectral efficiency with low power consumption. However, the increasing number of antenna does always increase the spectral efficiency because the power consumption also increases along with the number of antenna and more of number of users. Based on this analogy, many studies have been carried out to build energy efficient massive MIMO system. Now, move toward the signal detection. In massive MIMO system, due to the large number of antenna, the uplink signal detection became computational complex and reduced the achievable throughput. Also, all the signal transmitted by the user superimposed at the base station to create interference, which also contribute to the reduction of throughput and spectral efficiency. We can see in the figure a massive MIMO system with end user terminal and M antenna at the base station. All the signal transmitted by the end user terminal travel through a different wireless path and superimpose at the base station, which makes the signal detection at the base station complex and inefficient. There has been extensive research to find the optical signal detection method for massive MIMO systems that can provide better throughput performance with lower. Can our current mobile phones use massive MIMO technology? Every antenna embedded on the phone is used for transmitting and receiving data. The added number of mobile antenna means your device can send and receive more data at once. Since they will boost the uplink and downlink speed, today most of the flagship phones come up with 4x4 MIMO, and they have 2 times faster than the phones having 2x2 MIMO, as they will have two free antennas. Currently, iPhone X and iPhone 11 are equipped with 2x2 MIMO, whereas iPhone 11 Pro and iPhone 11 Pro Max and all these kind of mobiles are 4x4 MIMO. Although your phone does not support the massive MIMO system, you can still get benefit from the massive system as the connection would be more reliable and sensitive. Overall, the reliable connection and the higher data are always good to have, but you have to pay some extra bucks to use the massive MIMO technology. Machine learning and deep learning for massive MIMO system. Currently, both machine learning and deep learning are very crucial technology for the design of 5G and 6G network. Massive memory requires very complex optimization, and the traditional algorithm such as geometry, game theory, are very sophisticated and require numerous computing power. The dynamic nature of the machine learning and the deep learning could be instrumental for three complex analysis, and it could save a considerable amount of computational power. The machine learning and deep learning algorithms are useful during massive MIMO beamforming, channel estimation, signal detection, load balancing, and optimization of available spectrum. The use of deep learning and machine learning for massive MIMO. I've been studying a lot. During the channel estimation, channel data can be considered as a big data, and several machine learning tools can be used to predict massive MIMO channels. The accurate prediction of the channel by machine learning will significantly improve the throughput of massive MIMO system. The use of machine learning or deep learning for channel estimation in massive MIMO is shown in the figure. The summary of the massive MIMO system and its characteristics and benefits and challenges is shown in the table. The need for an efficient cellular system